Morning, welcome to math. This next video might be a longer one because the page we're working on today is word problems that have to do with fractions. And word problems in math often make math a little bit more complicated because we're adding an element of reading and figuring out what we're reading and then figuring out what we're supposed to do with math to solve the problem instead of just skipping to that use the math to solve the problem part. The cool thing about word problems is that these are the problems that you will be applying your math skills to in regular life. So it's important to get some practice with them. We don't use them all the time or very much, but we'll take in this video, I'll take some time and we'll go through each of these questions. I'll read them. I'll point out some of the important words to look for that will give you hints on what to do for solving them. Okay, so let's get started. Question 1, it reads, 5 out of 9, or 5/9, of the community pool is reserved for swimming lengths. What fraction of the pool is not reserved for swimming lengths? So for this problem, you need to know that 5 out of 9 means the pool is divided into 9 sections, and 5 of those sections are used for swimming lengths. So then what's left over for not swimming lengths? So for this one, if the whole pool would be 9 out of 9, right? You need to understand that if your top number and bottom number are the same, then you're showing a whole thing. So the whole pool, 9 out of 9, well, maybe 5 of those ninths are for swimming lengths, which leaves 4 for not swimming lengths. So the fraction that you're going to end up creating is 4/9. 4/9. Okay, I'm not going to solve all of these for you, but do the first one together, maybe the second one as well, and that might get us going. A picture of fruit drink is made by mixing water and canned orange juice. So we're mixing water and canned orange juice to make a fruit drink. Question A, if 1/4 of the fruit drink is canned orange juice, then what fraction would be water? So again, we need to have our understanding of fractions and whole things. So if 1 out of 4 parts is water, then the leftover parts are going to be, if 1/4 is the canned orange drink, then the other parts are going to be water. So let's draw a fraction bar as a model. I'm going to take one section and make it canned orange drink. And I know it's divided into 4 sections because the fraction that was used was 1/4. So how many sections does that leave for water? Little water drops in here. That's what I was trying to do. So you can see in my model that that would leave 3 out of 4 sections for water. So that would be your answer for the one for 2A. B says, how would the taste of the fruit drink change if 1/2 of it were canned juice instead of 1/4? So I guess you have to think, would it taste more? Fruit drink is usually sweet and sugary, and we know water is not. So if we had half of our juice be orange juice, would that make it more sugary or would it make it more watery? I'll let you answer that question. You can use my model to help see it. Number C, if you added some club soda to a glass of fruit drink, would the fraction of canned juice in the glass of fruit drink get bigger or smaller? And you need to explain. You might want to try and draw a diagram like I've been doing, add that third ingredient, and think about, would the fraction of orange drink get bigger or smaller if you're adding more of something else to the container? Remember, the container stays the same size every time. Number 3 is an interesting one. It says, this picture represents a set of stickers we've got squares, rectangles, triangles, some pointing up, some pointing down, and we've got white and black. So we've got some are white and some are colored in black. What are 2 examples of 4/9 of the stickers? So there's 9 stickers in total. What are 2 examples of 4/9? Well, one example would be 4/9 of the stickers. Maybe I'll just write 4/9 are black. And I wonder if you could find another example of 4/9 of those stickers. B says, what fraction of the stickers are quadrilaterals? And in brackets, it helps us with that math word in case we forgot what a quadrilateral is. It has exactly 4 sides. So let's count the 4-sided shapes and then write down the fraction where the bottom number of the fraction is going to be how many shapes there are in total. Now this next question, you really have to pay attention to the words because it's going to change the bottom number of our fraction. This time it says, what fraction of the quadrilaterals, not what fraction of all the stickers, but what fraction of the quadrilaterals do not have 4 equal sides? So if we look at our quadrilaterals, some of them have 4 equal sides. Some of them are squares, right? And some of them are not. So what fraction of the quadrilaterals do not have 4 equal sides? And the last question, what other category can be represented with the same fraction that you figured out in C? Okay. Number 4, this picture represents the fraction of the Earth's surface that is covered by water. Well, if we look at it closely, we've got 12 squares in our fraction bar, and 3, 4, 5, 6, 7 of them are colored black. So what fraction of the Earth's surface is covered by water, which is the shaded parts? And then I want you to tell me what fraction of the Earth is not covered by water. Which is there more of, water or land? Layla and Ray went to the park. This picture represents the fraction of time each spent on the swings. So it looks like Layla spent 4 out of 6 of her time. Ray spent 4 out of 5. So we've got the same number on the top and a different number on the bottom. So this is kind of what we were talking about in yesterday's lesson. Question A says, what fraction of the time at the park did Layla spend on the swings? Well, that's just looking at our question here and writing down the fraction. So Layla spent 4/6 of her time at the park. And Ray spent 4/5. Who spent more time? And I'll let you take a look to try to figure that out. The teacher is going to order 10 pizzas for a year-end party. More than half of the pizzas must be vegetarian. So 10 pizzas in total, more than half must be vegetarian. Will there be enough vegetarian pizzas if 3 are vegetarian? Yes or no? What about if 6 were vegetarian? Yes or no? If 6 pizzas were vegetarian, what fraction of the pizzas are not vegetarian? Give another example of a fraction that would have enough vegetarian pizzas by shading the pizzas below. If you wanted to, you could just shade however many pizzas are vegetarian and then write the fraction beside it. And remember, you need more than half of them to be vegetarian. Last question, a soccer team won 3/9 of the games they played this season. That's soccer team A, 3/9. Soccer team B lost 5/9. Lost. Okay, soccer team A won 3/9. Soccer team B lost 5/9. Soccer team C won 3/5. This is getting tricky. They won, so that's an important word, 3/5. Okay, What fraction of their games did Team A lose? Well, if they won 3/9, they must have lost the rest, which would be 3 plus 6 equals 9. So 6/9. So let's keep soccer Team A questions in black. 6/9. What fraction of their games did Team B win? So if soccer Team B lost 5/9, how many did they win? They would have won the other amount of games. And what fraction of their games did Team C lose? Which team won a greater fraction of their games? Team A, Team B, Team A or Team B? And which team won a greater fraction of their games? Team A or Team C? So interesting. I'm going to see what you do on this question. I might recommend drawing models or maybe comparing the fractions for each team and how many games they won, comparing those fractions to the fraction 1/2. And that might help you solve these problems. All right, if you watched all the way to the end, great job. Hopefully this helped you out.